verify. Where true of Rolle's theorem for the function y is x squared minus 3x plus 2. And first I remember the theorem of Rolle, the Rolle's theorem. I gave this theorem for you in our lecture. But I recall this here. If a function f of x is continuous on an interval from a to b, I'm sorry, and is differentiable at all interior points of this interval, and vanishes. At the end points, x is A and x is B, then inside interval from A to B, there exists at least one point x is C between A and B. At which the derivative f prime of x vanishes. It is Rolle's theorem. Let's see the verify of condition of this theorem. Function f of x must be continuous on the interval from A to B. Our function y is x squared y is x squared minus 3x plus 2 is continuous in each point of the interval from minus infinity to plus infinity. All on the set of all rational numbers. This function is differentiable at all interior points of this interval. then the function must be vanishes at the end points x is a and x is b. Let's find the point in which the function is vanishes. It means y is 0. From this, x squared minus 3x plus 2 equals 0. X first equals 1, x second equals 2. It means we must consider the interval from a to b or interval from 1 to 2. A is 1, b is 2. In this point, at this point, f of a is f of 1 is 0, the function is vanishes, and f of b is f of 2 is 0, 2. Then, inside this interval, consider our theorem. There exists at least one point x is C. The point C lies between a and b, at which the derivative f prime of x vanishes. F prime of x will be equal to y prime equals x squared minus 3x plus 2 prime, or 2x minus 3 equals 0. From this, 2x equals 3 and x equals 1.5. 1.5 is C that lies between 1 and 2. It means we verify the true of rules theorem for our function. Is it clear? Do you understand? This is example.
Yes.
Okay.
الله أشرف لما أشوفك عريس.
Yes.
Next. The example 5. The function f of x is 4x cubed plus x squared minus 4x minus 1 has roots 1 and minus 1. Find the root of the derivative f prime of x mentioned in Rolle's theorem. Solution. We can see that function f of x is continuous on each interval of the set of real numbers and has the derivative in this interval. In each interior point of this interval. The first, f of x is continuous on interval from -1 to 1. The second, f of x has the continuous derivative at all points all interior points of this interval the third f of x is vanish at the end point of this interval. It means f of -1 and f of 1 equals 0. It means inside this interval exists the point in which f prime of x equals 0. F prime of x equals 12x squared plus 2x minus 4. Or 2 times 6x squared plus x minus 2. Discriminant of this expression equals minus 1 squared minus 4 times 6 times minus 2. It means 1 plus 48. It means 49. X first, it means RA. Maybe X first. Equals 1 minus square root of 49 over 2 times 6 it means minus 1 over 2 and x second 1 minute please. X second equals 1 plus this root over 2 times 6. Or 2 over 3. X first belong interval minus 1 to 1 and point 2 over 3 lies between points minus 1 and 1. It means f prime of minus 1 over 2 equals 0 and f prime of 2 over 3 equals 0 too. The point C first equals minus 1 over 2 and C second equals 2 over 3. Is it clear? This example.
Yes, clear.
Okay, now I send in the chat this board, the photo of this board. Clean the board and we continue. Can you see the screenshot of the board in the chat?
Yeah.
Yes.
Now maybe I will check you and we continue. Abdallah Yusuf not, Abdul Salam Mohammed not, Abdurrahim Allah Ahmed not, Abdurrahman Marwan not, Al Abdali Mohammed not, Al Badri Bakir here.
Yes, I'm here.
Dr.
Yes,
Abdurrahim
yes,
Allah here.
Abdurrahim come, I see. Then I can see Daud Abdurrahman, yes. El Misiri,
Dr.
yes,
ده داود this.
Abdurrahim Allah here.
yes, I checked you, Abdurrahim Allah. Then Mohammed Abdurrahman here. Rezk Ahmed got Gamal got Ali here. Then who? Hassan Mohammed here. Hussein Khalid here. Shinuda here. There exists another student with you. Not? Okay, I save. I'm sorry, I killed. I cannot clean. 1 minute. Wait. Oh. Next number that we consider, it's example number 9. Form Lagrange's formula for the function y is sine of x on the interval from x1 to x2. I remember for you Lagrange's theorem, firstly. If a function f of x is continuous on the interval from a to b, and differentiable at all interior points of this interval, there will be within interval from a to b at least one point c that lies between a and b, such that
دكتور
yes,
مي مرزوق مصطفى بروبليما الانترنت بليز تشيك مي
I don't understand and what with Marzouk Mustafa who has problem with internet. What I can do with it?
I can't join to the page. The page.
He sit with you in one room? What with Marzouk Mustafa? He sit with you? Marzouk Mustafa with you? Or not?
Yes, yes, he is.
Okay. I understand you.
Yes. Thank you.
What I say? F of b minus f of a equals f prime of c times b minus a. It is Lagrange's theorem. In our example, we must form Lagrange's formula. It means this formula for the function y is sine of x on the interval from x first to x2. Consider the property of this function that verify of the condition of our theorem. The first, the function must be continuous on the interval from x first to x2. We know that function y is sine of x is continuous on each interval of rational numbers, of set of rational numbers. It means y is sine of x is continuous on interval from x first to x second. Then the second, our function must be differentiable at all interior points of this interval. It is true. The function y is sine of x is differentiable. At each point of this interval. And our theorem, Lagrange's theorem, give us that if to this property from function y is sine of x is true, is right, then exists the point C that lies between A and B, it means x1 and x2, in which we can form this formula. B is x second, A is x first. It means we have sine of x second minus sine of x first equals f prime. F prime of x is derivative of sine equals cosine of x. F prime, cosine of C, interior point, times x second minus x first. Is it clear?
Yes.
Yes, C
Clear.
lies between x first and x second. It was example number 9. Next example. Number 10. my example number 10. Verify the true of the Lagrange formula for the function y is 2x minus x squared.
دكتور
Yes.
خالد حسين خالد رمضان أيام هذا.
Hussein Khalid.
ده
I know, I checked you.
عندي مين بجلس
اوكي دكتور.
دكتور محمد عبد الرحمن كان تشيك مين
Yes, I checked you later.
okay thank you
Before. I'm sorry, before. What I said. Y is 2x minus x squared. X squared. On the interval from 0 to 1. Don't want. On the interval from 0 to 1. The first, y is 2x minus x squared is continuous on the interval from 0 to 1. The second, y is 2x minus x squared is differentiable at each point, at each interior point of this interval. It means is differentiable on all intervals. Form the Lagrange's formula. Y prime will be 2 minus 2x. Y of B minus y of C equals y prime of C times B minus A. Y of B, y of 1 minus y of 0 equals y prime of C times 1 minus 0. Y of B, y of 1, 2 times 1 minus 1 squared. Y of 0 is 2 times 0 minus 0 squared. It means 1 minus 0 equals y prime of c times 1 minus 0. From this, y prime of c equals 1. True. Sim. Y prime of c equals 2 minus 2c. 2 minus 2c equals 1. 2c equals 2 minus 1. c equals 1 over 2. And our point y over 2 lies between 0 and 1. We verify the Lagrange's formula for this function. Is it clear?
Yes,
Do you
clear.
understand it? Okay. Next. Картофельный пюре с курицей. Он не хотел. Next example. Example 17. Write the Cauchy formula for the function f of x is x squared, phi of x is x cubed on the interval from 1 to 2 and find c. I remember you the Cauchy theorem. f of x and phi of x are two functions continuous on the interval from a to b, and differentiable within it and phi prime of x does not vanish anywhere inside the interval, there will be found in interval from a to b some point x is c that lies between a and b such that f of b minus f of a over phi of b minus phi of a equals f prime of c over phi prime of c. We have two functions. F of x is x squared and phi of x is x cubed. and interval from 1 to 2. It means A is 1, B is 2. Consider condition of Cauchy's theorem. The first, f of x and phi of x are continuous functions on the interval from 1 to 2. Then the second, f prime of x is 2x and phi prime of x is 3x squared exists in this interval. Then phi prime of x equals 3x squared does not vanish inside interval. Form the Cauchy's formula. F of b minus f of a, it means f of b is 2 squared minus f of a x squared at the point 1, 1 squared over phi of b 2 cubed minus phi of a 1 cubed equals f prime of c is 2c over phi prime of c is 3c squared. Calculate. 2 squared minus 1 squared is 3. 2 cubed minus 1 cubed is 7. Is 2 over 3c. We can take out 1 degree of c. From this, 9c equals 2 times 7, 14. From this, c equals 14 over 9. 14 over 9, it is 1 and 5 over 9. This point lies between 1 and 2. We find this point. Is it clear? Do you understand these numbers?
Yes.
Is that clear?
Doctor, please,
Yes.
can you attend it maybe? يا رمضان أخ.
Can you see the boat in the chat?
Okay, thank you.
Ramadan Ahmed, I checked you.
Thank you.
You must see.
Hmm?
You must see the video of this class because it's not very easy.
YouTube?
Yes, I after this class I post this video on YouTube because right now I record our class. Understand me?
Okay, I understand.
After class I post it. Now I clean the boat and we continue.
Okay.
Next examples. We will use the L'Hopital's theorem. L'Hopital's theorem. Write down L'Hopital's theorem. Or rule of L'Hopital. Let the function f of x and phi of x in some interval satisfy the Cauchy theorem. And vanish at some point x is a. it means f of a equals phi of a equals 0. Then if the ratio f prime of x over phi prime of x has a limit as x approaches a, there also exists limit as x approaches a of f of x over phi of x, and this limit equals limit as x approaches a f prime of x over phi prime of x. 1 minute please, after 1 minute of time. Write down the theorems. Next example. Example 18. Using this theorem, we must find limit as x approaches 1, x minus 1 over x to the power of n minus 1. Now we have the indeterminate form of the type 0 over 0. We can write it in this way. In this case, we can find derivative of numerator over derivative of denominator. Find limit as x approaches 1. X prime minus 1 prime is 1. In denominator we have n times x to the power of n. or 1 over n times 1 to the power of n or 1 over n. Is it clear?
Yes, it's clear.
Okay. Next example that we consider, maybe. Number 32. We must again find limit as x approaches infinity of natural logarithm of x plus 1 over x over natural logarithm of x minus 1 over x. Now we have indeterminate form infinity minus infinity. We can use the Lagrange L'Hopital's theorem. In this case too. Only two cases, 0 over 0 and infinity over infinity. Another case not exists in this theorem. It means we must find limit as x approaches infinity. Maybe I write down as natural logarithm of x plus 1 minus natural logarithm of x in numerator. Into the denominator of natural logarithm of x minus 1 minus natural logarithm of x. Find the derivative. Prime. We will have limit as x approaches infinity 1 over x plus 1 minus 1 over x 1 over x minus 1 minus 1 over x. We have x minus x plus 1 over x times x plus 1 x minus 1 over x times x minus 1. We will have x minus 1 over x times x plus 1. Return the quotient that stay into the denominator x times x minus 1 over x minus x plus 1. Find limit as x approaches infinity, x minus x is 0, here 2, here don't exist, minus 1 times x minus 1 over x plus 1. And we have limit as x approaches infinity, minus 1 plus 1, or minus x plus 1, sorry, x plus 1. We have infinity over infinity again, and we can use the L'Hopital rule again. It means we must find limit of ratio of derivatives minus x plus 1 prime over x plus 1 prime. It is minus 1. Is it clear?
Yes, clear.
Okay. Next, maybe 47. Limit as x approaches 0 of 1 over x to the power of tangent of x. We have 1 over 0 is infinity, tangent of 0 is 0. Let y is 1 over x to the power of tangent of x. From this, natural logarithm of y equals tangent of x times natural logarithm of 1 over x. From this, okay. Find limit of natural logarithm of x, of y, as x approaches 0. Oh, sorry. It is natural logarithm of limit y. We will have limit as x approaches 0 why I write down infinity 0 tangent of x times natural logarithm of 1 over x. 1 over 0 is infinity, natural logarithm of infinity is infinity, tangent of 0 is 0, and we have indeterminate form 0 times infinity. Consider this, for example, as natural logarithm of 1 over x over cotangent of x, because tangent of x equals 1 over cotangent of x. And we have in this case infinity over infinity. We can use L'Hopital's rule. Они кончились, что ли? Ну, посмотри, если там внутри есть. It means we must find limit as x approaches 0 of derivative of numerator over derivative of denominator. Derivative of numerator. It is natural logarithm of 1 minus natural logarithm of x. It means minus 1 over x. Derivative of denominator. Derivative of cotangent minus 1 over sine squared of x. Or limit as x approaches 0 sine squared of x over x. And we have in the indeterminate form 0 over 0. We can use L'Hopital rule again. And we will have limit as x approaches 0 of 2 times sine of x times cosine of x. It means 0. We have that natural logarithm of limit y is 0. Zero is natural logarithm of 1. It means limit y equals 1. One minute, please. Алло. Да вообще-то не очень, у меня сейчас лекция идет. Минут через 5. Угу. Limit is of 1 over x to the power of tangent of x equals 1. Is it clear?
Yes, clear.
Yes.
At home, you must solve numbers from 1 to 52 this number. Now I create your homeworks. Goodbye, good luck to our class. I record this class because I post it in the YouTube channel. You can see if you want. Goodbye.